So in today's video we will look at characteristics of an virtualized environment. So what are the characteristics of virtualized environment? There are 7 important characteristics found in virtualized environment. First one is abstraction, second one is resource pooling, third one is dynamic resource allocation, fourth one is isolation, fifth one is mobility, sixth one is automation, seventh one is standardization. Now let's look at each one of it one by one. So let's start. First one is abstraction. Virtualization allows for the abstraction of hardware resources such as CPUs, memory, and storage, allowing them to be used by multiple virtual machines or containers. Detailed explanation of abstraction. Abstraction refers to the process of separating the physical resources of a system from their logical representations. It allows multiple logical representations of physical resources to be created and managed independently of each other. For example, in server virtualization, abstraction is used to create virtual machines, VMs, that can operate independently of the underlying physical hardware. The VMs appear as independent servers to the user, but they are actually running on shared physical resources, such as CPU, memory, and storage. Abstraction in virtualization environments enables efficient utilization of resources, as multiple VMs can share the same physical resources while operating independently. This means that physical resources can be dynamically allocated to different VMs as needed, increasing flexibility and reducing waste. Moreover, abstraction in virtualization environments helps to improve scalability and reliability. If a VM fails or becomes unresponsive, it can be easily restarted or moved to another physical server without disrupting other VMs. Overall, abstraction is a critical component of virtualization environments, allowing for the creation of efficient, scalable, and reliable computing systems. Now we should move towards second one. Resource pooling. Virtualization enables the pooling of resources across multiple physical hosts, which can be used to create highly available and scalable environments. Detailed explanation of resource pooling. So let's start. First, understand. Resource pooling is one of the key characteristics of virtualization environments, and it refers to the practice of aggregating physical computing resources, such as storage, processing power, and memory, into a unified virtual resource that can be shared across multiple applications or users. This concept allows virtualization environments to utilize computing resources more efficiently, as unused resources can be dynamically allocated to meet the needs of applications as they arise. For example, if one application requires more processing power or storage than is currently allocated, the virtualization environment can automatically allocate additional resources from the pool to meet that application's needs. Conversely, if another application is not using all of its allocated resources, those resources can be returned to the pool and used by other applications that require them. Resource pooling helps to ensure that computing resources are used more effectively and can also help to reduce overall costs, as it minimizes the amount of idle resources that are not being used. It also makes it easier to manage and monitor computing resources, as they are all centralized and can be controlled from a single location. Overall, resource pooling is an important characteristic of virtualization environments that helps to make them more efficient, flexible, and cost-effective. Let's understand now dynamic resource allocation. Virtualization provides the ability to allocate and deallocate resources on the fly, based on the current needs of the applications running on the virtual machines or containers. Detailed explanation of dynamic resource allocation. Dynamic resource allocation is a characteristic of virtualized environments that allows resources to be allocated to different workloads on an as-needed basis. It involves dynamically adjusting the amount of resources, such as CPU, memory, and storage, that are allocated to a workload based on its current needs. This can help improve resource utilization, reduce waste, and optimize performance. In a virtualized environment, workloads are separated from the underlying hardware and run on virtual machines, which can be moved and migrated across physical hosts. Dynamic resource allocation enables administrators to manage and optimize the resources available to these virtual machines. It allows resources to be allocated automatically or manually based on workload demands, and it can help prevent over-provisioning, which is the allocation of more resources than necessary. Dynamic resource allocation is commonly used in cloud computing environments, where multiple customers share the same physical infrastructure. It helps ensure that each customer has access to the resources they need, while minimizing costs and maximizing efficiency. For example, if a particular customer experiences a spike in traffic, dynamic resource allocation can automatically allocate more resources to that customer's workload to handle the increased demand. Overall, dynamic resource allocation is an important feature of virtualized environments that enables efficient and effective resource management, helping to optimize performance and reduce costs. Let's understand now isolation. Virtualization enables the isolation of applications and workloads from each other, providing a secure and stable environment for each application to run in. Detailed explanation of isolation. Isolation refers to the ability to separate resources and prevent them from interfering with each other. This is important because multiple virtual machines can run on the same physical host, and each virtual machine may have different requirements or workloads. Isolation can be achieved through several mechanisms, such as virtual networks, storage, and memory. For example, a virtual network can be created to isolate traffic between virtual machines, and virtual storage can be assigned to a specific virtual machine to prevent other virtual machines from accessing it. Isolation can also be used to improve security. By isolating resources, virtual machines can be protected from malicious attacks or unwanted access. For instance, if one virtual machine is compromised, other virtual machines can be protected from the attack through isolation. Overall, isolation is a critical feature of virtualization, as it allows multiple virtual machines to coexist on the same physical host while maintaining separation and protection from each other. Now take a look at mobility. Virtualized environments are highly portable and can be moved between physical hosts with ease, providing high levels of flexibility and scalability. Detailed explanation of mobility. Mobility refers to the ability to move virtual machines, VMs, or applications from one physical host to another, without interrupting the user's access or causing any downtime. This is accomplished through various techniques such as live migration, which allows a running VM to be moved from one physical host to another without any noticeable interruption to the user. Virtual machine mobility also enables other features such as load balancing, where workloads can be dynamically distributed across multiple hosts based on resource utilization, and high availability, where redundant VMs are created and automatically activated in the event of a hardware failure or outage. In addition, mobility also allows for better resource utilization and management, as VMs can be moved to hosts with available resources, avoiding over-provisioning of resources on individual hosts. Overall, VM mobility is a critical feature of virtualization environments, enabling better resource utilization, improved availability, and more flexible workload management. Understand automation in virtualized environment. Virtualized environments can be managed and orchestrated using automation tools, reducing the need for manual intervention and improving overall efficiency. Detailed explanation of automation. Automation in virtualization refers to the ability to automatically manage and provision virtualized resources without the need for human intervention. This is achieved through the use of automation tools and scripts that can automate tasks such as resource allocation, deployment, and monitoring. One of the main benefits of automation in virtualization is that it can significantly reduce the time and effort required to manage virtualized environments. This can help organizations to improve their efficiency and agility while reducing costs. Automation can also improve the consistency and reliability of virtualized environments by eliminating the risk of human error. For example, automation can ensure that virtual machines are provisioned with the correct resources and configurations every time, reducing the likelihood of configuration errors or security vulnerabilities. Additionally, automation can help to streamline the deployment and scaling of virtualized resources, making it easier for organizations to respond to changing business needs. For example, automation tools can be used to automatically provision additional virtual machines during periods of high demand, ensuring that applications continue to perform optimally without requiring manual intervention. Overall, automation is a key component of virtualization environments, enabling organizations to achieve greater efficiency, consistency, and agility in managing their virtualized resources. Let's understand standardization in virtual environment characteristic. Virtualization provides a standardized environment for applications and workloads, reducing the complexity of managing heterogeneous environments. Detailed explanation of standardization. Standardization is one of the key characteristics of virtualization environments. It refers to the use of standard technologies, protocols, and interfaces across the virtualized infrastructure, allowing for seamless communication and interoperability among different components of the system. In a virtualized environment, standardization can help to simplify and automate many tasks, such as deploying new virtual machines or managing resources. By using standardized interfaces, administrators can easily monitor and control the environment from a central location, without needing to worry about the underlying hardware or software. Another benefit of standardization is that it can help to promote compatibility and portability of virtualized workloads. This means that virtual machines can be moved between different virtualization platforms or cloud providers with ease, without needing to make significant changes to the application or its environment. Overall, standardization is a crucial aspect of virtualization environments, as it enables flexibility, scalability, and efficient management of resources. By adhering to industry standards and best practices, organizations can ensure that their virtualized infrastructure remains stable, secure, and cost-effective over time.